All right, in this video, we'll be implementing this wonderful project. It's an AWS 3-tier architecture, and we'll be implementing everything using Terraform. So, this is day 28 in 30 days of AWS Terraform. If you are new here, hello, my name is Piyush, and Cloud and DevOps is what we do all day long in this channel. My channel is known for simplifying the complex concepts, tutorials into bite sized chunks so that everyone can understand it. And this is a part of a 30 days AWS Terraform series in which we are breaking down Terraform from ground zero up to the advanced level. So, using this playlist, you will not be only able to get the required Terraform knowledge when work along with AWS, but also you'll be able to be job ready. You'll be able to clear any Terraform interview or any DevOps interview with the Terraform part from it. So it's an end-to-end series, and it's part of a 30 days of AWS Terraform challenge as well. The challenge details are given in the day zero video. Make sure you watch that and make sure you follow this series in the same sequence as the videos, because most of these concepts we have covered in the previous videos so that we don't repeat the same concepts again and again, and just to avoid some time. Okay, and if you are someone who don't have much patience in watching a long video, please, this video is not for you then, because these are the real time end to end projects, and it usually goes anywhere from 30 minutes to 1 hour to 2 hour, like whatever it takes, right? So there is no upper limit to it. If you have enough patience, then it will be really helpful. I promise you that. If you watch the video till then, and not just watch the video, watch the video, understand the concept that I explain in the video, and then try to implement everything on your own, on your environment, using the steps I provide, and try to add your steps as well, your logic on top of it, and that's where you learn. So when you break things, when you fix things, then uh, you only understand what's like how does it actually works, and then you will be able to explain that in the interview, right? Because in the interview, no one will ask you what is Terraform, what is CI/CD, what is infrastructure as a code, or you know uh, that's really really basic question, and no one asks those these days. So people ask the questions about what problems did you face when implementing, let's say, a 3-tier architecture using Terraform, or how's the architecture of cloud looks like in your organization where you work, or what type of deployment patterns, infrastructure as a code provisioning patterns are you familiar with, what are the benefits of one over the another, explain me the step by step process of how you would do that. Something like that. This is just an example, but you'll be only able to answer these scenario based questions when you implement everything by your own, not just watching the tutorials, not just reading blogs, not just going through some random videos, right? So if you are ready to do that, let's dive in. I'm not going to waste more time. So as you can see, it's a 3-tier architecture. So I'm just going to explain it to you what it is and why do we need each of these components. um so here's your user. Okay, so let's start with user. Okay, so here's your user over here. So user send the request to your web application, let's say something like example.com. Okay, www.example.com. So this is the domain on which your application is hosted. If it's too small, so let's just put it over here. Okay, so user goes over here, www.example.com, which goes through the internet gateway to the external load balancer. Okay, so why do we need external load balancer? External load balancer is needed so that we can distribute the load across multiple virtual machines placed in different availability zones. So over here, this is on the top, that's availability zone 1, and this one on the bottom one is the availability zone 2. So why do we need two availability zone? To make the application, to make the architecture highly available. Even if this entire zone goes down, you still be able to serve the traffic from the secondary zone because you have the similar identical infrastructure placed in the second availability zone for high availability. So we have, as you can see in the availability zone, we have two public subnets, one in each availability zone. And why do we need that? Because we are using NAT gateways in the public subnet and the Bastion host in one of the public subnet. Now, Bastion host is a way using which we can restrict the SSH connections to our servers, right? So we have like these are the front end EC2, these are the back end EC2 server. We don't want to expose each of these servers on their public IP address. We want to keep it private so that only encrypted connection to those servers would be established internally, right? So what we do for that, we create a Bastion host in the public subnet. So we restrict all the access on this particular machine in the Bastion host. I'm sure you will be able to see that in the Bastion host. And then this Bastion host has the connection to SSH to these front end and to backend EC2 servers. So this Bastion host is also sometimes referred to as jump box or jump server, right? You might have heard it if you are working somewhere. So jump box or jump server, because we use it just to log into one of the servers, right? So user first do an SSH into this. I mean, not the user of your application, but your, let's say, DevOps engineer, admins, sysadmins, your cloud administrators, and so on. So those people do SSH to the Bastion host, and then using Bastion host, they can log into their respective EC2 servers, whichever they want. Okay. So that's the importance of this. And I'll get back to NAT gateway, but I have to explain the rest of the flow first, and then we'll come back to NAT gateway. Then we have private subnet over here in availability zone 1 and private subnet in the availability zone 2. So why this is needed? So there is a difference between public subnet and private subnet, right? So public subnet in the virtual machines or the addresses or like instances in the public subnet have public IP address so that they can be accessed from outside the AWS cloud, right? But let's say we want to secure our server, we want to restrict the access to our front end server or back end server so that they are not directly accessed from outside. So it's an additional security layer that we are implementing. So what we do for that, we keep them in private subnet so that they don't get the public IP address. If they don't get the public IP address, they are behind a secured wall. Okay, this is a locked area private subnet, and only the external load balancer have access to this front end servers, right? So when, let's go back over here. So when a user log into your website or goes to a website example.com through the internet gateway to the load balancer URL, right? So example.com, so there will be a DNS record, okay, which points the DNS external load balancer. Let's say your external load balancer DNS is something like alb.xyz, something like that, right? So what we are doing, we are creating a record set, a CNAME record. I'm not going to explain what are records at DNS record, what are those, maybe later on sometime, but I have explained that multiple times in the previous videos. So you can watch the DNS video. I have a DNS video in my channel as well, or like, let's continue, right, for now. So there'll be, let's say, DNS address of this external load balancer is something like this. So what we are doing, we are creating a CNAME record which points to example.com. Okay, so whenever user hits example.com, it resolves this particular DNS. Okay, so that's what we are doing over here. And this load balancer has access to reach to this front end EC2 servers. Now, this load balancer will be doing health checks on the EC2 server. Let's say on a particular port, for example, port 80, right? This port 80 will become the health check port, and when we get the reply back from the EC2 server, that means the server is healthy, okay? And the server, the EC2 server will be part of external load balancers backend pool, okay, or the target group. Now, as soon as this goes down, server has some issues, it stopped responding on port 80 to a load balancer. Load balancer knows that, okay, server is not healthy, let's replace it with a new server. Okay, and because it's part of an auto scaling group, you see there is an auto scaling group symbol over here. So these two servers, even though they are on different availability zones, they are part of an auto scaling group, in which we have defined what we have defined in the auto scaling group. We have defined minimum number of replicas, maximum number of replicas, and desired number of replicas. I'm not sure where do I put this because my screen is already full. Okay, so I'll just keep it over here on the right. So minimum replicas, let's say minimum replicas are 2. What we are saying is there should be minimum of 2 instances running all the time in these two availability zones. Maximum of 4. Okay, because it's part of an auto scaling group, we have set certain threshold on this server. Let's say CPU utilization of this server goes above 80%, add an additional server, right? So the auto scaling group, using the launch template, keep adding more server till it raises the maximum number of replicas, which is 4. And desired, let's say, is also 2. Desired is like if the load is minimum, if there is no additional action is required, just keep two servers running. So whenever we provision the infra, two server will be running all the time. Okay, and let's say we have set an auto scaling condition which says scale down when there is less CPU utilization. It will not go down below the minimum number of replicas, which is 2. Okay, so that's the auto scaling group. Now we reach let's go a step back again. Okay, I'm spending more time on it so that you can understand what goes behind the scene, what is the purpose of each of these component. Otherwise it will be really difficult to understand. But because you are here in video 28, I'm sure you have fundamental knowledge of AWS, which is kind of a prerequisite of this video, but I'm trying to explain whatever I can and making sure that video doesn't go out of the scope of this series, right? So so okay, users come here, internet gateway, load balancer DNS. There will be a CNAME record which will point website to the ELB. Then ELB will redirect the traffic on the front end port. So user will see like the application running on this front end EC2 server. Now because this is a 3 tier architecture, so we have a front end which is tier 1, we have a back end which is tier 2, which is also called as logic layer. So this, if we call it tier 1, it's presentation layer, right? Presentation layer which users see on the browser, on the application homepage, right? So this is the presentation layer. Then we have tier 2, which is your backend server. This is also called as logic layer or the business layer. So this is where your application logic actually resides, which does the processing, which does the backend operations and so on, right? So your now you have two servers over here, and there could be more because it's part of auto scaling group. Now these all will send the request to an internal load balancer. Okay, so understand the difference. This was the external load balancer because it is exposed outside. Okay, people are just hitting to the DNS URL directly with the help of DNS record, but yes, so it is exposed outside. But this load balancer is internal to our application, to our AWS account. So only the front end server will be able to reach to this internal load balancer, so that this further can distribute traffic across the backend EC2 server, which is also part of an auto scaling group in separate private subnet. Okay. Now we have another private subnets for database. This is also called DB subnets. Okay. In that there is a primary database. So this database could be any RDS, any managed database service that we are using, RDS, Amazon Aurora, or anything. And there'll be a primary database. So all the requests, all the read and writes from both the EC2 servers will go to this primary server. Okay, so this will be main. This is also called master slave architecture of database, in which there is a primary server and another one is secondary server in a different availability zones, again for high availability. Now everything is taken care by this primary server, but there is a synchronous replication going on between primary and secondary database servers over here, right? So whatever writes are going over here, it will then be returned to the secondary database. So these two servers are on sync. Okay, so let's say we have added something over here, so it will be then added over here with the help of this replication process that's been going on, right? And why do we need that? So we need to make sure that we are keeping both the servers up to date with the latest data, so that in case of a disaster, so that in case of like let's say availability zone goes down, so front end servers will be these, back end server will be these, and this secondary server will become the primary server. Okay, when failover happens, this secondary server will become the primary server because this server is no more there, and this server has the latest data, so it is the identical copy of the main production database. So this can become the main production database, which is the primary database. Okay, so that's tier 3. Tier 3 is DB tier, or the data tier. Now, this is a 3-tier architecture which is highly available and fault tolerant. Highly available because even if one zone goes down, another zone is there which can serve all the traffic. Fault tolerant because if one EC2 server goes down, or let's say if there is more load on the server, it is able to spin up more servers because it's part of an auto scaling group. These are the managed database service. So these databases can also be scaled in real time as the load increases on that. So that makes it fault tolerant. And if you have more requirement, let's say if your application is highly production critical application which needs even the regional failover as well capabilities, right? So now that we have two availability zone, we can have two regions as well. So this entire stack will be copied to another region, and then there are different disaster recovery techniques. Like we have active, passive, warm, standby, and active, passive, warm, standby, and I think there is one more, backup and restore, right? So we are not covering that in this video because it will be a little off the topic. Not off the topic, but it will be something that we are not implementing in this video, because those are mostly required when you need your application like highly available, but then it increases your cost as well, because now you are provisioning like whatever this is into two, so you will be paying double the cost of your infrastructure, depending upon the disaster recovery techniques you're using. But that is mostly used for regional failover, and when you need high availability in multiple regions, that's when you use it. But if it's not required, like you can save a lot of cost over there, right? So that's why we're not doing it. So this is yeah, so this is the architecture. Now you must be thinking, because these servers are private subnets. Okay, there is one more thing. So as you can see, there are containers running on each of these virtual machines. So I have not deployed the application directly on these EC2 servers. Instead, I have installed Docker runtime, and then on top of that, Docker containers running for front end, for back end, and so on, right? Now, when you run a container, when you spin up a container, it needs to pull the Docker image, right? It needs to, and also EC2 servers also need to download some updates. How would it download? Your database also needs to be upgraded from time to time. How would it download the upgrade when they are in private subnet? That means they don't have outbound internet connectivity. How would you do that? And that's where we need NAT gateways in the public subnet. So NAT gateways, the main usefulness or the main feature of NAT gateway is it helps you. Let's say this backend server need to download a Docker image from the Docker hub, which is over here, right? So I'll just write it down. That's Docker hub or Docker, any Docker registry, right? So how would it download the image from here when we don't have the outbound internet connectivity, because this is private subnet? So what it will do, this backend server will go out from NAT gateway. Like the route that we configured in the route table is through the NAT gateway. So it goes over here to the NAT gateway, and then NAT gateway will then send the request back to internet gateway. Internet gateway goes to Docker Hub, and this is the way the image will be downloaded to the EC2 servers. Same for other EC2 servers as well, right? For the front end, back end, database, right? So try to understand this flow that I've just explained, right? These backend server needs to download some updates, needs to pull the images from Docker Hub, which is out here in the public internet. How would it do that? Because they are part of private subnet, they don't have outbound internet connectivity, and we need to keep them in private subnet to secure them, to highly secure them. And also databases and backend should always be in the private subnet. That's the rule of thumb, right? So for that we need to add NAT gateway in each of these availability zones, because NAT gateway does not span across multiple availability zones. So we need to have one NAT gateway per availability zone, so remember that. Okay, and it's a managed service. So like earlier, long time back, we used to have, when we didn't have NAT gateway, we used to have NAT instances. NAT instances work the same way, just they were self-managed EC2 servers on which we configure everything. We need to take care of maintenance of it and a lot of other things, right? But it's a managed service, that means it's costly as well. So make sure you delete the infrastructure once you are done with the demo. Okay. So yeah, so as I was saying, it goes down. The route table will have entry, so there'll be route table associated with these subnets, which will have the entry that when these backend servers has to go out to the public internet, it goes through this route, like from here to NAT gateway, and from NAT gateway to internet gateway, which then goes to Docker Hub, and then it comes back with the reply, right? So this is what we are going to implement. I am sure you would have understood the end-to-end flow, all the things that I have explained over here, and now we'll be doing the demo. And by the way, we'll be using CloudWatch. CloudWatch is using is used for auto scaling group, because it needs to monitor the utilization of servers, right? CPU, memory. Based on that, it will trigger the auto scaling groups. Secret manager is what we are using to store the credentials of, Docker pull or any other database credentials. All those credentials will be stored in the secret manager, and it will be injected in the containers, and over here it will be used in the runtime, right? So this is highly secured. Okay, so I think we have covered enough about this. Now let's go inside the code, and I'm going to explain you through that, and then we'll provision the infrastructure. All right, so I am in my GitHub repository. This is the day 28 folder. Make sure you pull the latest changes. Okay, so over here you will see different folders, right? So there is a folder for backend, Docker, local deployment, front end, and Terraform infra. Okay, so backend, front end, all these will have code, Docker file, and so on, right? Terraform infra is what we are mostly concerned with. So inside that there are environments. So currently it only has dev environment. So you can replicate this to staging and production, multiple environments. So you just make a copy of these this folder, dev folder, and make some changes in the variables. So this is what we have done in previous videos as well. So I'm not just gonna go through that, but let's go through the configuration of dev environment. Okay, so what we are doing, we are using the data source, we are gathering the details of AWS account ID and AWS region, like the current region and the current login credentials from which I have logged in already. Then there is a random password generator resource type, which will help us generate a random password with length 16 characters with some special characters, and we are excluding some special characters, because this will be used as a DB password for the database. And it has certain restrictions like what type of password we can use, what type of password we cannot use, and so on, right? Then we have multiple modules. Now these modules are placed over here in the module folder. Okay. So modules, again, this is something that we have explained multiple times. What is modules, how to create it, what is custom modules, how to source it. So this is what we are doing. So module is VPC. Okay. Source is two directories back inside modules folder inside VPC folder. Okay. So which is over here. Okay. And inside that there is a VPC module. Inside that there is main.tf. So this particular block is calling this module and passing all these values to the modules. What values, and from where we are getting these values? We are getting these values from the variable. So var.environment, var.project, VPC, front end, and enable NAT gateway is true, then single NAT gateway or not, whatever, right? So these values are stored over here in the variables.tf. Okay, and you can create a Terraform tf var as well. I have just placed it over here in the default value. So here's the CIDR block. Environment is of type string, but I have not placed it because again it will be inside the this folder, right? Main.tf variables, right? Here we have provided the value as dev. Okay, so this will override the other file, or you can just uh, copy this file, adjust the values, and rename it to terraform.tf vars. So it will use all these values. Okay, if you don't do that, I believe every value has been placed over here in the default section over here, right? So like public CIDR, it's a list of string with multiple CIDR blocks. Again, there is availability zone, list of string, front end, subnet CIDR, everything is there. And yeah, whatever value is not placed over here, it will be there in the VPC module over here. For example, a value of this, like enable NAT gateway, single NAT gateway equal to false. So this is some variables that we have used. Okay. Now, I think we need to make this change as well. Or maybe not. We'll see. We'll see. First, let's just continue the walkthrough. Okay. And yeah, I think we need to replace our Docker Hub username over here so that we can build the image and we can push it to the to our repository. Okay, so that's fine. Let's go back to main.tf in the dev environment. Okay, so that's the VPC module. The next one is security groups. So we need to restrict the access. Okay, so let's see what is there in the security group modules. Security group module is over here, main.tf. So first we are creating an inbound rule, HTTP from internet. Okay, and this will be placed on load balancer, right? Because as I've told you, load balancer will be accessed over public internet over port 80 and 443, HTTP and HTTPS. So we are creating this security group for ALB with inbound as 80 to this CIDR block and inbound as 443 for this CIDR block, and then this CIDR block for outbound access as well. Okay, and then here are some tags. Now there is a security group for internal load balancer. Now as you can see, from port 80 to port 80, so we are opening port 80 for the inbound access, but for this security group. Okay, which security group is that? This is the security group associated with the front end instances. Okay, so the security group with the name front end. Okay, and that will be accessed over here. Egress is fine. Then we have security group for bastion host. So this is where we are providing the allowed SSH CIDR. What all the allowed SSH CIDRs for which SSH access is granted on port 22 for the bastion host. Okay, and then security group for front end. Now if you'll see, for front end we are opening port 3000. This is where our Docker containers are running, and this is only for the ALB security group. Only the application load balancer should be able to access the front end EC2 servers on port 3000. Okay, and there'll be a SSH access as well for the bastion host. So as you can see, only the bastion server will be able to do SSH on these front end servers. Okay, so, and egress is here. Then security group for backend. Now for the backend server, port 8080 is exposed, but for internal load balancer only. Right? If you remember the diagram, only internal load balancer should be able to access the backend servers, and bastion host on port 2022 for the SSH. Then there'll be security group for our RDS server, our database. Okay, so 5432 port from the backend server. So we can only do only create the PostgreSQL connection from the backend server on port 5432. Okay, and that's what we have configured. And no outbound traffic is allowed. Okay, so that's all the security groups we have. Now let's go back to main of the dev environment. So then we have IAM modules. So IAM module, it's let's see what's in there. Go back over here. IAM main.tf. So it will have certain roles attached to the EC2 servers. So this is the IAM role for EC2 server. What it is assuming the role for EC2 so that it does certain operations on behalf of us. Then we attach AWS manage policy for session manager so that we can do the like login on these EC2 servers. Then attach AWS manage policy for CloudWatch, because again, CloudWatch need to monitor the EC2 server, so it should have certain permissions to do that. Then policy for secret manager access, because what we are doing, we are gathering the value of secret from secret manager at the runtime, right? For database secrets and so on, right? So it should have the permissions to get secret value and describe secret. Then then we need to attach the policy to certain EC2 servers, and IAM instance profile. Okay, and these are all the operations that we would have done manually otherwise. So the same thing we are doing from the Terraform. Then we have RDS module. Okay, so all the information are there, and like database, it is generating the database from the random password resource that we have created earlier and storing the result from there to the to this variable db password. Okay, and that db password will then be passed over here to the secret manager module so that a secret will be created, and that secret will be accessed later on from the server itself. Okay, that's RDS module. So let's go inside RDS over here, main.tf. So it has a DB subnet group, right? Because we need to create a separate subnet group for database, and it's called AWS DB subnet group. Then DB parameters, like which Postgres family we need to use, some other parameters like log connection, log disconnections, log duration, right? And then the instance details. So here is the database engine version, storage type, and these values are coming from the variables that we have passed from the environment. Here's the port and all rest of the details, like it's multi-AZ. So there is a variable for multi-AZ. If we don't need multi-AZ, the value of variable would be something else. Let's see if it's over here. Multi-AZ, or it is coming from the, yeah, it's over here. So default is false. We are not enabling the multi-AZ deployment for this. You can change this value. Okay, and also it says there is a condition over here which says availability zone equal to var.multi-AZ. Let's say if it is false, then use the availability zone as null. Otherwise, use the value inside var.availability zones. And then all the other details. There is a lot of details in database, so all the details are over here, like um, final snapshot details, monitoring intervals, and so on. Now we need to have an IAM role for enhanced monitoring, and this is what it is. We need to monitor those RDS servers. So we need to attach this, like create the role and then attach the role as well. Okay. Now let's go back. RDS it's done. Now the next is secret manager. Secret manager we already know, but let's just check this. Inside modules we have secrets. Go to main.tf. So we are creating AWS secret manager secret for DB credentials. Okay, and we have a lifecycle policy to prevent the accidental deletion in production. And here is the data of that DB credential, like DB username, password, engine, host, port, DB name, right? All those details. And where is yeah, DB password is over here, which is coming from the other variable. If we can check the variable over here, DB password is sensitive, but there is no value over here. But if we go to this field over here, so it is coming from random variable, random password dot db password dot result, and then it is assigning this to db password variable, and which is what we have used inside the module. Okay, the next is bastion. Okay, so the bastion host, let's check the module for bastion. And the reason why I've created this modular approach, because this is one of the best practices, right? You are controlling what can go inside each of these variables. You are restricting it from the module so that it can be reused as well. And others are also using the similar type of uh, templates that we have created, right? They are not creating their own value, something that is not supported or not secure enough. So over here, we have a data source for AMI. We get the AMI, then Elastic IP for Bastion host. We are creating an Elastic IP. And there is Bastion host EC2 details, instance type, key name, subnet, user data script. So there is a user data script. Let's check this script as well inside the script folder, I believe. Um, Over here. So backend use, no, just user data. Where it is, path module user data, it is where it is. Okay, over here in the same folder. Okay, what we are doing, we are, because we need to create an EC2 server, then we need to make EC2 to act as a Bastion host, right? In Azure, there is a managed service for Bastion. I believe in AWS it's not a managed service, so you need to manage your own Bastion host. So what we are doing, we are installing some tools on that, like vim, git, stop, wget, and so on, installing docker on that. And then we are installing AWS CLI, installing session manager plugin. And then we are, what we are doing over here is we are setting some values of the variable. We get the details from the metadata of AWS CLI, and then we are just setting the terminal prompt over here, some aliases, some permission settings, and so on, right? So now this will become our Bastion host. Then we'll go back again. The next is ALB. Okay, ALB is target group port is 3000, on which it will be connecting to the front end servers, because this is a public. It has a public prefix with the name public hyphen, and there are the subnet details. Okay, now there is internal load balancer as well, and it will be sending the traffic, or it will be doing the health checks on port 8080 of the backend servers. Then we have front end ASG module, application security group for the front end. Similarly, we'll be having the module for backend application security group, and here are all the details like minimum, maximum, desired capacity, and so on, right? So yeah, these are all the resources. So let's try to build the application now. First, what I'll do is I'll try to do Docker login. Okay, my username is this one, and my password is whatever I've added. Now the Docker login has been done. Now what I'll do is I'll go inside the front end directory. Where am I currently? Lesson 28. CD Terraform infra. Oh no, not the Terraform infra. From the front end, we need to build the Docker image with the code that we have over here, right? Now, what we can do is we can build using Docker build command. Okay, let me just clear the screen. Docker build hyphen t. Oops. Docker build hyphen t, and then my username, which is this one, then my repo name, let's call it goal tracker front end, which is the application that we are deploying, and let's tag the image as v1 dot. So my Docker is not running. Let's start the Docker. Okay, it's running now. Let's run the command again. Okay, it's now the Docker. Let's check this. Docker images. Here is my Docker image that's just been created. Now what we can do is we can push the image, Docker push, and we already tagged it, so we can just use Docker, like we can just use the tag name Steva hyphen this, oops, and then goal tracker front end colon v1. Okay, oh, not v2, sorry, v1, and it should be pushed in my Docker hub registry. And now the same way we can go inside the backend folder and run docker build hyphen t deva hyphen goal tracker backend colon v1 dot, and I'm just gonna copy the name this time, and then we'll just push this backend image as well to the Docker hub, to the same repository. Should be done quickly. Let's pause the recording. Okay, so it took 13 seconds or so, but it's done now. So let's just use Docker push to the backend. Okay, it's been pushed. Now what we can do is we can just go inside the Terraform directory, Terraform infra directory, and what we can do is we can go inside the dev folder, which is this one. We can just make the copy of it, okay, and rename it to, like, remove the dot example from the end, and now we can just make the changes over here. Okay, so let's keep it us east 1 dev goal tracker. Let's keep all the values, it's fine. And let's give it key name, replace with your key name, like your ssh key name. So let me check my ssh keys, and I place the name over here. Actually, let's create it without the key pair. It's fine. Let's allow it SSH to this because my IP will keep on changing. So there's no point of using that. Then Bastion instance type is T2 micro. That's fine. Front end instance type is this. Backend configuration RDS DB username. If you want to create multi availability zone database, then you need to make it true. I'll just keep it as false. DB backup retention as 7 days. Okay, db skip final shot or snapshot. Then we have docker hub configuration, so make sure you replace this with your username so that it knows which image to pull. Okay, leave empty for the public image, else you need to use your username and password. But again, you can also use secret manager to store this docker hub password. But let me check if the repository that I have created is public or not. Okay, so let's go to docker hub. Okay, let's do sign in. Okay, and my repositories are these two are by default public repositories, so we don't have to provide the password. Should be able to pull the image. Then there are some tags, and that should be it. Now you need to deploy the infrastructure. So in this directory, so you have to go to this dev directory so that it will take this terraform tf vars. And did I create the backend.tf? I think that's missing. So make sure you create the backend.tf. It's not really a good practice. I might have missed it, but let me just double check. Yeah, I think it's not here. So make sure you use a remote backend. And we have used that in multiple videos, so I'm sure you know how to use that. For now, I'm just gonna go to environments, dev. Okay, let me set the alias tf is equal to terraform and then run terraform init. Okay, it is initializing because we have created all the modules, so it needs to initialize and install the modules to download the dependencies and so on. Now you can run terraform plan, and there'll be a lot of resources, plus rds takes a lot of time to provision, so you have to be patient. But I will pause the recording so you don't have to just stare at the screen. Okay, so 67 resources to be created, so I'm gonna run terraform apply hyphen hyphen auto approve and hit enter. So I'm gonna let it do its work, and I'll pause the recording for now. But if there is any error, I will unpause the recording and we'll troubleshoot the error together. Right? Hopefully it should be created. So let me just pause it. So there were a couple of minor errors which I have just fixed, and those were minor errors. Hence, I'm not telling you what those errors are because I want you to do the troubleshooting. You will face the error, and I want you to do the troubleshooting. It's pretty simple, straightforward. Error message has the details, so you should be able to fix that if you are following along the video. Okay, so this is also a test for you, for me to watch if you are actually following the video or just doing the fork of the repo and executing it. This is where the actual learning starts, when you do the troubleshooting. Okay, I'm sure you can do that. Now there is this error now I'm getting after, even after making those changes, which says modifying rds db parameter group, there is some invalid value, and the invalid value is for log connection. Allowed values are this, so let's check what these are. We need to check this resource aws db parameter group. So let's go to Terraform documentation, which is AWS Terraform provider. And I can just directly search for that resource that I've copied, AWS DB parameter group. And inside RDS, okay, over here, now the value for which it is throwing the error is log connection, which should be good as per this. Um, let's see. Mm, 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 mm. Let's search it over here. If we see it in the parameters, so name and value. Okay, and let's search for log connection. So there is just one value, and Here we see the value is 1, but over here it is throwing the error. It says log collection allowed values are receipt authentication authorization setup, and it doesn't match with what we see over there, right? So let's go back and we try to search this somewhere else. um AWS DB parameter group. Okay, maybe I'll check the AWS documentation. AWS RDS and Postgres. The version that we are using is 18.1. Okay. Um, no, it doesn't show anything. So let's check log location RDS Postgres. Let's check the user guide. Okay, so here is the value. So log connection default log each successful connection, and okay, so that's log statement, log minimum duration. Let's search it over here. Log connection. So there is just this one thing. Let's check something else. Nope. Log connections. Okay, so who is accessing database? Okay, so it is logging the connection. What type of connection it is logging, and change it value from off to on or 1, which is often the value in this. So I think they have recently done something with the latest Postgres version, because I'm using 18.1. So let's try to use a previous version. Like 15 had some issues, 15 is deprecated, 13 is really old. So maybe I'll use 17, and let's see if it is there. No. Yeah, so doesn't show much details over here in the documentation, you can see. So I don't think using LLM would be of any help either. So let's try to do one thing. Let's try to go over here, parameter group. Let's delete this parameter group, or just keep it and we'll create a new one. That's fine. And let's check the AWS RDS Postgres, which versions are supported. Okay. Over here, and let's check the version details. Nope. Versions. Okay. So Postgres 17 we can use, 17.7, maybe let's use that. So I'm gonna go over here in the DB engine version 17.7, and there'll be one more place, I think inside RDS. Mm-mm-mm. RDS over here, we can just change it to PG17, because we want it to create a new one. Okay, and Postgres 17 is the family. Okay, and this is where it is throwing the error. I'm not sure why, but that's okay. We'll try again. Okay, so we'll try with this now. Let's check and let's hope there is an issue with the latest version and maybe the documentation is out of date. That is what I'm hoping. Okay, it created the DB parameter group and now it is creating the DB instance. I think it would have failed if there were any issues. So it did not fail. Maybe that fixed the issue. So sometimes you see using the latest version of any resource creates the issue because documentation is out of date, right? And that error they were capturing the error beautifully. Like in the error they have provided valid values are these, but we don't have it in the documentation and we don't know what that means, so we cannot use it, right? So that's why I have used the previous version. So I'm just going to pause the recording while it's provisioning the database instance. All right, so okay, yeah, after few minutes, I believe it took around 20-30 minutes or so, all the resources, everything is now up and running, and I'm getting some output over here as well. So it should have, here's the application URL, which is your load balancer URL. Okay, and here are some output variables that we have provided that you can use. The main is the DNS name for the application load balancer, right? Where our application will be listening. So this is the application. Okay, so let's say hi, hit enter, goal added. That means the record has been stored in the database with the help of backend. And then if you remove it, it will be removed from the database and you can check the resources that have been provisioned. Okay, over here, so you can check the DB instance, right? Here's the database instance, and then events. Okay, there are some logs that have been generated. That's fine. Now you can go and check other resources as well. So ALB, you can search for elastic load balancer. Load balancers over here. Okay, over here I see one internal load balancer and one external load balancer. Okay, so if you check the public load balancer, and if you see there is a listener with HTTP 80, and this is forwarding the traffic to target group. This target group is nothing but where your two front end servers are listed. Okay, these are the two front end instances, both are healthy, and on port 3000 it is doing the health checks. Okay, the same way, if you go back and check the internal load balancer, this is the target group for that, and for that there'll be two backend instances, dev goal tracker backend, and the port is 8080. You can check now the auto scaling groups. So there'll be two auto scaling group, one for backend, one for front end, with two instances, two desired, two minimum, and max 6 and 4. That's what we have specified. And here are the launch templates in the EC2, because we are seeing four servers over here. So in the EC2 as well, there'll be four running server. Fifth one is, what's the fifth one is the Bastion host. Okay, which is over here. Now you can log into the Bastion host, hit connect using a public IP. Let's hit connect. Okay, now from the Bastion host, I've logged into the Bastion host. From the Bastion host, I can now log into the EC2 server, right? So if we go over here, EC2 front end, let's say, okay, and it wouldn't have the public IP because these are in the private subnet. So let's copy the private IPv4 and do SSH Ubuntu at the rate the private IP, and yes. Okay, permission denied because I don't have my keys over here in this particular server. So this is the task for you. Okay, Transfer your keys. Okay, let me full screen. Transfer your keys to the bastion host. Using that key, SSH to the front end server and to the backend server. Try to log in to the RDS on 5432 port from the backend server and try it from the front end server. See whatever is working and which should work, okay, as per what we have seen or as per our diagram, as per our code. Now also try to SSH into front end server from not from the bastion host but from your local machine and see what error you are getting. Okay, ideally it should time out because we have not configured the security group in that way. It should only be allowed SSH from the bastion host, but I want you to try it out and this is how you will learn, right? So make sure the last step, make sure you destroy the infrastructure, and let me do that before I forget. Okay, otherwise it will cost you a lot. um, tf destroy auto approve, but make sure you do enough testing, make sure you check out everything before you actually hit destroy, otherwise it will take a lot of time to provision it again, and I'm sure you won't do it. So try it out. The destruction should be quick. It just database will take some time, and rest database and load balancer will take some time. Rest should be fine. So while it's doing, that's it for this video. I hope you had an amazing learning experience. If you did, share it with your friends, colleague, whoever you think could take the advantage of this learning opportunity. Make sure you complete the task. Make sure you create your own architectural diagram, because this three-tier architecture is something that I recommend to everyone, right? This is not the first time we are doing this video. We have done this video in 10 weeks of cloud ops challenge as well. It just, in that video we did it manually, everything was done manually. This time we did it from Terraform with some additional features, with some additional security configuration. So make sure you create the diagram, create the blog, post it on LinkedIn, Twitter, whichever platform you're comfortable with. But this will help you gain some visibility. This will help you learn the networking and infrastructure components of AWS and how do we manage it using Terraform. It's like, in a nutshell, it's an important project and you should have this in your resume if you haven't created it yet. Okay. So that's it. Thank you so much. Happy learning. I will see you again with the next video. We have two videos left and it will be posted this week. So wait for it. Thank you so much for watching.